Well, it's great to be here. I'm Seth Spielman. I'm with Microsoft. But I also care very deeply about national statistics, and I serve as a scientific advisor to the US Census Bureau. And I'm more here talking about the census in that capacity, and I'll let Alex introduce himself.
Yeah, thanks, Seth. So I'm Alex Singleton, so I'm a professor of Geographic Information Science at the University of Liverpool, and I run something called the Consumer Data Research Centre there. Seth and I have kind of worked on this area for a great number of years, and this is sort of the latest iteration of sort of quite a long series of ongoing collaborations building geodemographics for the US.
Yep. Great. So what we're hoping to do in our short 15 minutes is to communicate 3 ideas. They might not be big ideas, but 3 ideas. The first one is that in public statistics, in data from the US Census Bureau, there's this funny trade-off between geographic resolution and demographic resolution. We're used to a world where when you zoom in on a map, things get clearer, but the opposite is actually true when you're dealing with data from the US Census Bureau. As you zoom in, things get fuzzier. The second thing we want to convince you of or communicate is that working with one variable at a time when you're dealing with really complex social and economic phenomena is difficult and a pain, and there are ways, better ways of handling high-dimensional information, which will present the geodemographic approach. And lastly, when you're working with very high-dimensional information and you want to communicate results to people, large language models can be really helpful. They can help you summarize very large and complex data sets down into sort of easy to understand summaries. And so with that, we'll begin on this first point, that block group, does this work? No. No. The first point is that block group data from the American Community Survey is mostly useless. This is not me saying this. The US Census Bureau in official documents and in the Federal Register argues that block group data should not be used by itself. That block group data is the highest resolution demographic data that's made available from the US Census, and at that scale, the errors in the data are so large, or the margins of error are so large, it's very, very difficult to use. So you might know that a neighborhood is 20% of the people in a neighborhood live in a block group, live in poverty, plus or minus 15% or even 25%. The data is highly uncertain. This paper in Demography discusses all of this, but the key takeaway is that block group data is not designed to be used by itself, both according to official Census Bureau publications and just best practices. And
so for those who aren't familiar with what a geodemographic is, very, very briefly, a kind of geodemographic sort of 101. Broadly speaking, what they are categorical measures of neighborhood structure. The process of building a geodemographic goes from these raw data inputs, like Seth was describing, through a series of different processing steps to produce clusters which kind of represent different categories of the area. So the first stage is that you gather a whole series of inputs. Typically there's an empirical evaluation of the variables that you might want to use, and it's based around some element of sort of theoretical framework about the drivers of residential differentiation. Elements of sort of classification builder experience go into that as well in terms of what variables are important for driving patterns. Elements of this, transformation happen, so it can be normalization or standardization is required, so everything's measured on the same scale. The main method which you use to actually turn those input measures into the clusters is cluster analysis. Most commonly used is k-means. If you came to the workshop yesterday by Eli Knapp at UC Riverside, he went through that whole process in Python. Once you've got the clusters, essentially for every single area in the country that you've looked at, you've got a label, so it might be cluster 1, cluster 2, cluster 3. You've got to turn that into something that is, has a narrative and a description. So the very standard way in which you do that is you create a whole series of propensity scores for those clusters, and then classification builders like myself or Seth will then look at these tables and then come up with creative labels and descriptions of those. Sometimes you might involve external parties to kind of validate those assumptions that you've made when you're writing the descriptions and check that they're kind of useful for purpose. But it's a really very, very lengthy process. And actually, once you've got all of that together and you've got your labels for the clusters, then you can map it. And obviously, we're all here for Carto, so you only map it on Carto. I believe other mapping platforms are available as well. So, for the classification we built, the kind of theoretical framework for that, we built it around an economy, environment, and population domain. And then underneath those domains, a whole series of input measures which we took from the ACS data at block group level. I won't go through all of those, but essentially, with Seth being sort of ex-academia and myself being from an academic background, we tie this to kind of a literature of, in terms of the processes by which sort of residential differentiation happens within cities. We're starting off with around 697 variables. We look at things like the variance of the variables, whether there's missing elements to it. So we try and discard problematic variables. We then do a very large correlation analysis, this sort of messy diagram that you can see here. We build a kind of network of correlations, so we see which variables are correlated with one another. We try and exclude things that are highly correlated. So we go through this sort of iterative process, and we whittle down the variables, and in this case, 247. So 247 variables for every block group in the country is quite difficult to describe. So what we do is, once we've generated these propensity scores for the clusters, rather than Seth and I having to sit in a room and try and work out what all these numbers mean, and actually we've done that for previous versions of the classification, and I mean, Seth will attest, it took us a very long time to motivate ourselves to get those finished, like as in years. So what we decided this time round was to try and use GPT-4 to help us with that process. So we've actually come up with a reasonably efficient pipeline for generating what are fairly credible descriptions, which I'll talk about some of the evaluation in a second. There's 3 stages to the way that we engineer a prompt for this. We set up a prompt, we describe the tasks that we want. So we're a geodemographic classification builders. We want a description of neighborhood structure. We've got a propensity score table for all these different features of the clusters. So we have to show sort of GPT-4 how to interpret those scores. So what the scores mean, what are significant scores, so how you actually identify what GPT-4 should be talking about in its returned results. We then, after that, present a propensity score. So we have a way in which we formulate the propensity scores into a table that GPT-4 can understand. We adjust some of the labels in terms of what the Census Bureau statistics say to things that are more interpretable, again, to assist in the quality of the outputs. And then finally, we do a kind of cleanup process where we describe the exact tasks that we want. So we talk about things, what tense GPT should return in. And then there's some quirks in GPT-4 of certain phrases or things we don't want to talk about. So we kind of list those out as well. I said it was successful. It was very successful. We created fairly rapidly over a couple of days, 39 for each of these sort of the clusters that we built, sort of 500-word descriptions. And that's okay. You could say, okay, off you go. We want to write this up for an academic journal, so we actually did some sort of manual validation on this. And this actually is an incredibly slow process, probably as slow as writing the labels. But on average, for each description, we counted up there's around 25 facts in each of the 500 words. There was a mean error rate of around 4%, so 64% had sort of missed features that might have been included, but that tended to only be a sort of one single thing. And actually, it wasn't an error as such. It was just some element of the statistic which might be missed. And often that was actually just missing an element of a range. So if you're talking about 15 to 18-year-olds, actually maybe you should have talked about 15 to 24-year-olds in that instance. There was hardly any supposition, so it didn't really lead to any sort of strange conclusions, and there was very limited repetition as well. So overall, it was actually quite a successful process. But those obviously, in terms of what we'll eventually release, we've been through those and kind of edited those to make sure that they're kind of clean and safe to use. I'll take through this very, very quickly. I say we will release all of this. We actually aren't selling this, so it's all completely free, and it will be, sort of available through our GitHub pages over the next month or so. We did a bit of ground truthing in the spring because we both happened to be in Denver at the time, and we went around some of the neighborhoods just to sort of check whether these clusters and descriptions kind of made sense of what we saw on the ground. So. I'm just going to whiz through these really. So one of the clusters is sort of described as diverse professional enclaves, reasonably large houses. This particular one was kind of in a gated community. These are slightly denser houses, multicultural urban professionals. In this particular instance, it was a kind of out of town, an out of the urban center development on the edge of Denver. But you find a lot of these clusters also within cities as well. More rental, for example, than the previous cluster in this particular example. We've got a slightly less affluent neighborhoods. This is, we've got the name of this one, diverse cultural mosaic. And again, there's sort of high linguistic diversity in this particular area. Again, lots of renter-occupied housing. And a slightly different cluster, and one you'll probably find if you looked on our map, sort of surrounding Columbia University. This tends to be found in sort of dense urban cores, particularly around universities, and has sort of a highly educated sort of population.
Okay, so we've argued that you can take very noisy, sort of high precision, high dimensional information about neighborhoods or block groups and turn them into these sort of easy to understand clusters. And we've shown that GPT can sort of save anyone some energy in summarizing the clusters. But the question is, what do you do with it? So why are these things useful? And one of the things that we found in the past is that there are many things of interest in the real world that are hard to explain one variable at a time, right? So here we're looking at an eviction data set that's published by Princeton, and you could look at the eviction rate by income, or you could look at it by race, or you could look at it by urban and rural, or you could look at it by age, or you could look at it by education, or you could look at it all at once. And through this classification, here we're looking at the variation in eviction rates across the kind of higher level of our classification. So you can see that there are certain kinds of neighborhoods that have a much higher eviction rate than others. And there are certain kinds of neighborhoods that have a much greater variation, or block groups, I shouldn't say neighborhoods. There are certain kinds of block groups that have a much greater variation than others. And then here we're looking at the patterns nationally, but we could also drill in. And here we're looking at the patterns in New York State over time. And so we see that there is one particular type of neighborhood in New York State, a diverse community. Some of the GPT-ness comes out in these, and that everything gets called diverse because it's got lots of different names. But this particular type of neighborhood has a much, much higher eviction rate than other neighborhoods. These are the top 5 neighborhoods in terms of their eviction rates, but even within that, there's this standout. And some of this is novel. That is, eviction rates tend to be high among neighborhoods with young, highly educated people in cities, not just in some of the kinds of places that you would expect. So we've presented this open source national classification, which is done at the block group level. We think doing something like this is really important if you want to use the block group data, just because it's so noisy. We've talked about using GPT-4 to sort of summarize high dimensional stuff, which is just generally useful. And we've shown how this classification can sort of help you summarize things that have sort of complex underlying causes and patterns. And that's it. Thanks.